Welcome viewers, in this video we will see the voltage regulation of alternator, zero power factor method, ZPF method or Potier triangular method. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Power factor is zero power factor method, voltage regulation or Potier triangular method. The test to be conducted for ZPF method are first is OC test, open circuit test, short circuit test, AC test and ZPF test. So from these three tests we are able to find the voltage regulation. The conduction of OC and ST test is the same as done in the EMF and MMF method. So from the MMF and EMF method we can able to get the OCSE test. The readings can be taken from EMF and MMF method. Separate video available for EMF method and MMF method. How to draw the OC curve and how to draw the AC curve. How to conduct OC test, AC test and how to draw the curve. Now we'll see the ZPF test. These two tests can be taken from EMF and MMF method. Now we'll see the circuit diagram for ZPF method. So this is a circuit diagram available. So this is an alternator. We need to find the regulation of this three-phase alternator RYB. The phase sequence is given. This alternator is coupled with the DC motor. The DC motor, in order to run the alternator, is coupled with the DC motor. This is the field excitation of the alternator, that is excited separately with the DC supply. Field winding is excited from the DC supply. Now we'll see the DC motor side. So this motor is connected, coupled to the alternator. DC supply is given. The 2-pole switch is there called S1 and it is connected through the 3-point starter, line, field, armature. This field is given with the variable resistance. This is the field winding of the motor. So the current flowing through the field winding can be varied by varying this rheostat R1. The value is R1. So we can control the current flowing through the field winding using this rheostat. The value is R1. This alternator is connected with the voltmeter and ammeter. This ammeter is connected in series. We can measure the armature current. And the voltmeter is connected. We can measure the voltage. And also wattmeter connected, W1 and W2. Because this method is zero power factor method, the zero power factor is verified with the wattmeter. Here triple pole switch is there, that is called S3 and inductive load is connected. In order to check the ZPF, we are connecting inductive load. Now we'll see this field winding, how we are varying the field winding. Current flowing through the field winding of alternator is connected through the DC supply through the double pole switch S2, right? So this is S1, S3 and this switch is S2. Is connected across the potentiometer. So current flowing through this field winding can be varied from this potentiometer. This value is R2. Earlier one is R1. So by varying this we can able to control the current flowing through this field winding. Right. Now what is the method? First one, the switch S1 is closed. That is the motor, DC motor switch is closed. By varying this resistor R1, the current flowing through the field winding is varied and we have to run the motor at the rated speed. Switch S1 is closed, DC supply is given. In order to make the motor to rated speed, the field winding, the current flowing through the field winding is varied by varying the resistor R1. Now the motor is rotating at rated speed, so that this armature or this alternator also rotating at a rated speed. Now the switch S3 as well as S2 is closed. Both S3 and S2 is closed. Now our aim is ZPF. So this field winding, current flowing through the field winding of alternator is varied by using this resistor R2, potentiometer R2. So that is given at the condition that is already inductive load is connected. So we have to check the ZPF, zero power factor at the wattmeter. Until that we have to vary this field current. Once it reaches the zero power factor, we can make it finalize. right? So current flowing through the field winding of alternator is varied until the zero power factor with the inductive load. At that zero power factor, we have to measure the current IA, voltage and field current. The field current at this instant is called a field current at ZPF. Similarly, voltage is voltage at ZPF. So I will explain again. First, the switch S1 is closed, so the motor start rotating. The current flowing through the field winding of DC motor is varied by varying R1 in order to make the rated speed. Thereafter, switch S3 and S2 is closed. The field current flowing through the field winding of alternator is varied by this resistor R2. This inductive load is connected at zero power factor. Until zero power factor, this field current is varied. Under that field zero power factor, the corresponding field current is called IF at ZPF. Similarly, voltage is voltage at ZPF. Also, we have to note down the current. Now we'll see the description what we discussed. So the switch S1 is closed and start the motor. Vary R1 and run the motor at rated speed. Close the switch S2 and S3. By varying R2 and the inductive load, apply the rated current at zero power factor. We have to find the rated current at zero power factor. Now we'll see what are the readings we need to note down. So now note down the reading of IF, IA and V. These three readings were field current, armature current as well as voltage. So we already discussed that the OC test and AC test we can done from EMF and MMF method. From OC test we will get the reading of IF and VOC. That is nothing but field current corresponding to open circuit voltage. And short circuit test IF, IASC and V, that is short circuit current. IA is the short circuit current, IF is the field current corresponding to short circuit current of IA. This is the rated voltage. So voltage, not a rated voltage, it is a rated current only given, it's a voltage. So from zero power factor test what we are getting IA, IF and voltage, that is voltage at ZPF, this is field current at ZPF. From all these value ZPF can be done. Now we got the ZPF readings. See already we have OC test and AC test as well as ZPF test. So from this reading we are able to draw the curve and we are able to find the regulation of the alternator. Now we'll see the graph. So from OC test reading, plot the OCC curve between the value of IF and VOC. See the graph. So this graph is drawn between IF, field current, and this value is VOC, open circuit voltage. So this OCC curve drawn from the OC test. So drawn from IF and VOC. Next one, we need to find the point A, this point A. This point A is nothing but short circuit current at zero voltage. At zero voltage short circuit current from SC test. That will give the point A. So this is nothing but short circuit current at zero voltage. So point A is identified. Then point P. What is point P? That is nothing but corresponding field current at ZPF, voltage at ZPF. So that only we identify from the ZPF test. Field current is varied until ZPF. The corresponding voltage will give voltage at ZPF. Field current is nothing but field current at ZPF. That will give the point P. Now join the point A and point P parallel to OC curve. So you have to join not a straight line. You have to join A and P, that is very similar to OC curve. Now we got the ZPF curve. Point A is nothing but short circuit current at zero voltage from SC test. Point P is from ZPF test, voltage at ZPF, IF at ZPF will give point P. A and P is connected, that curve is parallel to OCC curve, very similar to OCC curve. Now we got the ZPF curve. Now we'll go for the further detail. Right, the next step is we have to draw this line. We have to draw the AIR line. What is AIR line? That is tangential to the OCC curve will give the AIR line. Just a tangential line. The tangential line to the OCC curve is AR line. Now corresponding to this OA, we have to draw the line QP. The QP is equal to OA. With the length of OA, we have to draw the line PQ. That is from point P, we already know. So from point P, we have to draw the point Q. So this length is equal to OA. Then draw the line which is parallel to this AR line until meet the OCC curve. That will give the point R. Now connect R and P. So that will give the triangle. The point P we already know. Draw the line PQ. PQ value is equal to OA. OA value is equal to PQ. From Q, draw the line parallel to AR line where it meets OCC curve, that will give R. Now connect the P and R. Now we'll got the triangle. Now this RS, draw one line, perpendicular line, that will give the point RS. This RS is nothing but IXL drop, right? Inductive drop. Then PS, this PS is nothing but FAR. This FAR, we know that is the to overcome the armature reaction, field excitation required to overcome the armature reaction. So now we'll got the value of IXL and FAR. Now from this E1 phase, this E1 phase is calculated from the formula. From this parallelogram theorem, we are able to find the E1 phase value. From E1 phase, draw the line where it cuts the OCC curve. Draw the perpendicular line, that will give FF1. That FF1 is corresponding to the value of IF1. From that we can find the value of IF1. So E1 phase calculated from the formula. Then draw the line where it cuts the OCC, draw the perpendicular line, that is nothing but FF1. That FF1 is nothing but the field current from the OCC curve, the value of field current IF. Now from this FF1 and FAR, these two value, we are able to find the FR value. So this is the FR. This point is FR. Now this line is not available. This point is the FR. The FR is the vector sum of FF1 and FAR. From that we are able to find the FR. From FR, draw the line, draw the vertical line where it cuts the OCC curve, draw the horizontal line, that will give the E phase. E phase value. From E phase we are able to find the voltage regulation. So our final aim is to find the E phase. So I will explain again. First draw the OCC curve. Then find this point A, that is nothing but short circuit. From the short circuit test, short circuit current is OA. With this, then find the point P. That is nothing but the voltage at 0 pf and current at field current at 0 pf, 0 power factor. Connect this A and P, which is very similar to OCC curve. Then draw the line P to Q. This length is equal to OA. Then draw the AR line. That is nothing but tangential to OCC curve. Parallel to AR line, draw the line R where it meets, that is point R. Then connect this R and P, so that we will get the triangle. So in this triangle, this value is nothing but IXL. Draw the vertical line that will give the point S, that is FAR. Then E1 phase is calculated from the formula. From E1 draw the line where it cuts the OCC curve, the corresponding will get the FF1. The FF1 and FAR, vector sum of these two will give the FR. FR, draw the vertical line where it cuts the OCC curve, draw the horizontal line that will give the E phase. So from the E phase with the value of V phase, we are able to find the regulation. Regulation is nothing but E phase minus V phase divided by V phase into 100. So our final aim is finding the E phase. So this is the procedure. So what we discussed, the description available. Now we'll see the description. What we are did in a sentence form. Description is available. Now we'll see to mark the point A. Now we have to mark the point A on x-axis. Point A is obtained from the short circuit test reading. In short circuit test, the value of voltage at short circuit AC equal to 0. That is, the point A is plotted between the value of field current IF and 0 voltage at short circuit test. In short circuit test, what is the field current at 0 voltage? That is, point A equal to IF, 0. That is, IF at 0 voltage from AC test. So the voltage is 0 and current IF is available. That will give the point A. Now we'll see the point P. How to mark the point P. The point P is found from the ZPF test. It is plotted between the values of voltage at ZPF and IF at ZPF. That is, IF at ZPF, voltage at ZPF. That we got from the ZPF test. This field current is varied to become the 0 power factor. At that time, field current is noted and voltage is noted. That is nothing but field current at ZPF, voltage at ZPF. Now the ZPF curve is drawn from point A through a point P and it is parallel to OCC curve. Point A we got, point P also we got. We have to join these two from point A to point B. That should be parallel to the OCC curve. Now a line PQ equal to OA. Already OA the value we know. Equal to OA we have to draw the point PQ. P also already available. So PQ, you have to draw the PQ. PQ value is equal to OA. That is parallel to x-axis. So now we got the line PQ also. Now AR line. Another one is AR line. To draw the AR line or RC line. The AR line is tangential line to the initial portion of the OCC. For OCC curve, drawing tangential line is referred to the AR line. Now draw a line QR parallel to the air gap line. It meets the OCC at point R. So already PQ is available, right? So we are drawing the line QR that is parallel to air gap line. Where it meets the OCC, that will give the point R. Now join the point PR. Already P available. Now it is PR is joined together. From point P, drop a perpendicular to meet a line PQ at the point S. So we have PQR triangle, and also while drawing the perpendicular line, we got the point S. I will go for the further. The value of RS gives the value of armature leakage reactance IXL. So RS equal to IXL. So what we discussed in the graph, where now this description is available. We already discussed the IXL is RS. The value of PS will give the value of FAR, that is, which is required to overcome the value of armature reaction. So PS equal to FAR. So we know that RS equal to IXL. So IXL equal to length of RS divided by I. Right? This I is brought in the denominator. So RS by I, length of RS by I. Now we are able to find the value of E1 phase. So from the available value, we are able to find the E1 phase. E naught air or E1 phase equal to V phase cos pi plus Ia Ra square plus V phase sin pi Ia XL. So this Ia XL already we got from the graph RS, right? So that this V phase value already known, cos pi value also known, Ia Ra also known, Ia XL is calculated found from the graph. This plus symbol indicates lagging, minus symbol indicates leading. Now we got the value of E1. Now corresponding to E1 phase, find the value of field current, that is called If equal to FF1. Corresponding to E1, we from the graph we easily calculated FF1, that will give the If from the OCC curve. The resultant current Fr is nothing but vector sum of FF1 and FAR. FAR already calculated, F11 also calculated. Vector sum of these two will give the Fr. Now we'll see the formula. It can be found from cosine rule as follows. Fr equal to square root of Ff1 square plus Far square minus 2 Ff1 Far cos 90 plus or minus pi. Right? So the plus symbol indicates lagging, minus symbol indicates leading. Now we got the value of Fr. So from Fr we need to find the E phase. From E phase we can able to find the regulation. Now we'll see how to find the E phase from this Fr. Now corresponding to Fr, find the value of E phase from the OCC curve. We already discussed how to find the E phase from the Fr. So now E phase is calculated. By using this formula we are able to find the regulation. Percentage regulation equal to E phase minus V phase divided by V phase into 100. So that will give the percentage regulation. Our final aim is finding the regulation. For that what we need is E phase, that is calculated. So E phase, from that we are calculating regulation. So in this video we discuss regulation of alternator in zero power factor ZPF method, or it is called a Potier triangular method. We discuss what is the procedure and how to draw the curve. From that how to find the E phase. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.